Good afternoon, everybody. Welcome to this Shaping Subtransmission webinar. My name is Ben Godfrey, and I am the Network Strategy Team Manager for Western Power Distribution. So this East Midlands study on the Shaping Subtransmission work has got a number of outputs on it, and today I'd like to take the chance to go through some of these outputs. This is an interactive webinar, so we're happy to take questions through. There's if you can look through your software interface, there should be a section there to ask questions. There will be on the dashboard through to us. You're free to ask questions all the way through the session, but we take a bit of a Q&A session at the end and put some answers to those questions, if that's okay. So throughout today's webinar, then we're going to have a look at the study objectives of what the Shaping Subtransmission work contains. We will have a look at the East Midlands background, understand what the specific conditions of the East Midlands are, how the network runs. We will look through the modelling and scenarios that we use within this process to derive at the results, and then we'll explore these a little bit with some recommendations as well. And then finally, we'll have a little look to the future and see what Western Power Distribution is doing to address some of these issues, and looking at how the way we plan to change some of the business aspects to more adequately reflect the needs of our customers. So the Shaping Subtransmission work really looks at forecasting the growth of demand and generation across 4 economic and environmental scenarios. To do this, we assess the thermal and voltage constraints of these scenarios, and we assess the ability of the existing network to be able to cope with the new demand and generation connections that we predict to be taking place in our area. This work is also furthered from the other study work by running some fault level analysis, some high level fault level analysis, and we're able to better understand how those trends are going to be occurring throughout the distribution network and provide some results on those. And we've taken those modelling results and assessed these against options for reinforcement. And this is really for 2 main aims. One is to provide stakeholders with the advance notice of the likely constraints in the area, but also recommendations for low regret investment that we will take inside the business and use for a basis of planning. So in terms of the background to the East Midlands, this network was predominantly designed just for demand. We're seeing at the moment that our maximum demand is slightly above 5 gigawatts, so about between 5 and 5.5 gigawatts, and our minimum demand is below 1.9 gigawatts. We've seen this quite change significantly over the past few years with the amount of growth of distributed generation that we've got in the East Midlands. So we've seen certainly the minimum demand start to reduce, particularly significantly in some areas. So on this slide we also see a table of our connected, accepted, offered and inquired position across the East Midlands. I think what's interesting to note there is the spread of generation that we've already got connected on the network. So we've got a fairly significant amount of PV as the single biggest technology type. But there's quite a lot of significant other generation as well. So it's not just a massively PV dominated network. We have generation running all the time on the network. And we have a total of 3.3 gigawatts connected at the moment, with a further almost 2 gigawatts accepted and in the pipeline to be built. What's also significant is the amount of energy storage offers that we have, or connections we have at the moment accepted and offered, and in quite a significant amount of inquiries on our network around that energy storage. So a lot of interest in there, and we're continuing to deliver more and more connections and capacity for customers. So we've seen a lot of the inherent capacity already on our network taken up by the connected and contracted generation. And because in some areas we've reached the limit of what the network is able to accommodate, then some new generation coming onto the network are finding being hit by large cost and timescales for that kind of reinforcement. So the East Midlands is one area where we have progressed our alternative connection arrangements to try and allow customers to get connected quickly and more economically onto the network. But this isn't just the distribution constraint. We've also seen significant transmission constraints as well in this particular area. So we've had an ongoing statement of works process with National Grid to assess what the impact of distributed generation on the transmission network is, and we've been passing down those messages through to our customers so they can understand the likely impacts of those. We've also seen a change in the number, the size, and technology type of applications. So a few years ago, we were heavily receiving many applications for solar PV technology. We've seen those reduced down due to the government subsidies, and then the most recent amount of applications has really been focused around the energy storage, which continues to get sort of significant interest. We expect to see a further change again when we get out to 2020 with solar generation reaching grid parity and starting to come back on stream again. I think what we can say on the government intention to move towards a low carbon economy is that there is still significant impetus to do that. This slide here references a bit of work or some reports of the middle of last year, which really reiterates the need to include all that low carbon generation and get it connected onto the network. Had we written these slides yesterday, then we probably would have included a little bit about the 2040 announcement for electric vehicles, or for diesel vehicles and petrol vehicles to be banned after that time period, which of course is going to have a significant impact on the uptake of low carbon technologies in the area. So I think it's clear to say that there is significant impetus still to try and achieve these, and so this isn't a journey that we're sort of we've cracked and we've finished. We will be continuing to connect more low carbon technologies onto our network. So moving towards the scenarios that we have benchmarked our analysis against, these have really been taken from the 2016 National Grid Future Energy Scenario document. It's changed somewhat for within the 2017, but it still effectively holds. There's 4 scenarios, split the base down across 2 axes, prosperity and a green ambition axis. We see that with little prosperity and little green ambition, we're more on a low progression route, which will be kind of more business as usual and just continuing in the path that we're going at the moment. Whereas as we start becoming having a lower carbon economy as a higher agenda and more economic activity in the UK, then we move either towards the slow progression or consumer power scenarios, and finally going towards this gone green scenario, which is in the 2017 FES document by National Grid has been changed, retitled to 2%. So it is the only credible solution that allows the UK to achieve a climate change target within 2%, which is the only legal solution across these. But of course, we're using these 4 scenarios to drive a range of investment options and understand how those different trajectories of development will impact upon our network. This forecasting work has been completed by Regen, who are our partners in this piece of research. In terms of methodology, then we start with a stage 1 baseline, which uses our current data to understand and validate the existing connections connected onto our network, and splits that down by technology type and geographic area to allow us to really understand where we are now. We then take this forward into a stage 2 pipeline projection, which looks at all of our connected and accepted capacity and projects what those schemes are going to be doing, when they're going to be building, and taking into account some of the external constraints and factors, either network constraints, but predominantly subsidies, planning regimes, and things like that. That kind of takes us to a 2020 position. Going forwards to a 2025, 2030 scenario, we're really going out to a much wider market intelligence model, and we're looking at how we can bring in information from stakeholders, look at any sort of other market material that we might have, and apply those future scenarios that we talked about earlier against what we think a predicted pipeline is going to be for growth in the East Midlands. And that takes us out to the 2030 position. If we see now for demand growth in the East Midlands, then we're starting from this just over 5.5 gigawatt of peak demand, and we can see that there's quite a fairly static position with a slight increase out to 2017, 2018. But once we go forward past the 2018 picture, we can see then that the higher economic scenarios have a significant uplift in the amount of demand that we'll be expecting. And that's really going to be coming from the low carbon technologies, the more economic activity driving demand growth across those areas. And we can see once we get to a sort of 2030, then we've had a shift up to almost 8 gigawatts worth of peak demand, which represents a significant increase above our current status quo at the moment. The distributed generation growth is somewhat different, particularly the beginning trajectory for that. You can see here that we've got quite a significant ramp rate of generation planning to build in the next few years. Obviously, this information is taken from our accepted pipeline, so many of those schemes will be waiting for reinforcement schemes to go ahead and for other schemes to be completed before they can be connected. It's quite a significant steep ramp rate there. We see that as a kind of short-term hurdle, and then as we start going out towards the 2018 onwards, we see the growth scenarios again operating in a range between that no progression and that gone green scenario, but certainly we see generation growing in the area and not reducing. In order to get the network models and the network modeling activity completed, then we have had to split our region down into smaller geographic chunks. This has enabled us to model the subtransmission network with better granularity and apply a more of a regional approach for our future scenarios and our pipeline projects as well. We've concentrated for this network modeling on the subtransmission network. So this is the grid supply points at 400 or 275 kV down to 132 kV, and then also the further WPD-owned subtransmission network, so the 132 kV network and our bulk supply points. We're focusing particularly on the subtransmission network because the network there tends to have longer lead times and it's more expensive to upgrade, so we feel it's the right strategy to target that for our modelling purposes. Our traditional modelling has focused on representative days, and this has, our traditional analysis has focused very much on a single edge case, so the peak demand and the peak generation output and the minimum demand conditions. But through using this techniques on the shaping subtransmission work, we have looked more at representative days and doing a half-hour model for each time period during the day. This has allowed us to go and get a much greater range of what we think is going to be happening and enables us to get better results on where we think the network will be operating. We've done this for a whole range of network scenarios, so both an intact network and other outages have been analysed, and this has enabled us to make sure that we're still providing a secure network for all of our customers. The generation and demand profiles have been built up using historical data, and we've predicted that into the future to see how that will map across to the different scenarios that we're modelling against. And then further on, we've used automated network modelling to be able to run a number of scenarios and a number of different modifications to enable us to carry out a full range of analysis all the way from 2016 through to 2030. So on to the results then. The next few slides will give a flavour of the sort of key messages that we found across the network, and highlight some of the constraint points and resolutions that are already in place across our network. So for instance, Berkswell grid supply point, we see that once we start getting towards the later scenarios, then supergrid transformer capacity is a particular constraint. What we're proposing and doing in this particular area, we've proposed within the network strategy work as a low regret scenario investment product would be to overlay the 132 cable sections and also reconduct some of the overhead line 132 kV circuits. By doing this, we can increase the network capacity in the area, and we'll be able to deliver enough capacity for those future demand and generation loads in that area. Once we start getting on to 2025 and beyond, then there's the potential to add a fourth supergrid transformer, which would of course would require liaison with National Grid in order to achieve that. Grendon GSP has both demand and generation driven reinforcement requirements. These are primarily against the SGTs for both demand and generation, and then more significantly for Northampton as demand and Corby as generation. So in those particular areas there, those are the ones which we'll be likely to be looking to upgrade in order to meet the future expectations of customers in those areas. We've already identified a number of works within our previous investment planning timescales, and so we currently have works ongoing in the area looking at the overhead line reconductoring on the 132 and cable lays, and we also implemented active network management to help facilitate generation connections in the area. Our recommendations in the report are to look at replanting the Grendon 132 kV board to be able to run solid, so that needs replacement for fault level issues. And there are also some further works that we've identified, such as the 132 circuits to Northampton and a new GSP potentially in the 2025 and beyond scenarios. Staithorpe again is demand and DG driven, and we have similar constraints in the SGT capacity and some of the different BSPs that make up the Staithorpe GSP. So they are either for demand or generation, or a little bit of both in there. And in order to overcome those constraints there, we've recommended some SGT increases or additional SGTs, and completing some of the reconductoring works and cable overlays in the surrounding area. A similar story for Walpole, in that it requires both demand and generation driven reinforcement. However, a slight difference with the Walpole group is that it's heavily dependent on the adjacent distribution network operator UKPN and their Peterborough network. So we're currently undertaking a joint study work with UKPN to more closely understand what their future customer needs are and what our customer needs will be, and to see whether there's any strategic work that we can do across the border in order to strengthen and make our network more resilient, whilst also providing the correct capacity that customers require. The main hotspot in this particular area is the Bourne area network. As I say, that's for both demand and generation. We've got 132 kV rebuild works going on at the moment in that area, but to meet the future needs that our modelling scenarios suggest, then there's further 132 kV overhead line reconductoring, other switchgear and transformer, additional plant requirements that will be needed. Willington is a pure demand-driven reinforcement. We can see this particular area has seen quite significant commercial growth, or is expected to have significant commercial growth in the area. There's a number of hotspots in there around supergrid transformer capacity and other bulk supply point areas. And there are a number of proposals that we have identified in terms of replanting equipment to cope with future fault levels, looking at cable overlays and replacing some supergrid transformers and grid transformers with larger equipment, and also securing with some further 132 kV circuits. Full details of all of these identified schemes are contained within our report, which is available on our website. So in terms of summarising all these results, then the main aim to take away from this today is that these are very much heavily scenario dependent, and it's really critical in why we're carrying out this analysis work, understanding what all the load and generation growth is from our stakeholders in the area, making sure that we are geographically tying them into the right particular areas, making sure that we understand as much as we can how those pipelines are currently progressing, and then fitting in with the future network scenarios that may be influenced by government policy and future government policy. So once we've identified these particular scenarios, then whether the real load and generation requirements are manifest earlier and the works need to be brought forward, or whether we can use alternative techniques to defer that reinforcement and push the investment spend back later on. Either way, it just gives us the flexibility. But once we've sort of designed the recommendations, then we have a strategy moving forward that we can pull those, either bring them forward or defer them, depending on how the local load conditions are occurring on the network. But I think what's really important to note here is that there is significant interaction between demand and distributed generation. And we've shown that in some circumstances where demand and generation can come along in tandem together, then they effectively cancel each other out, and we can operate the network using existing assets without having to have heavy reinforcement spends. But of course, if the demand and generation isn't working in exactly the same sort of timescales, then we do need to reinforce the network to accommodate that. For fault level, we've completed a number of high-level studies to understand where we think the distribution fault levels are going. And I think the main interesting thing to note from this is that despite what the variances on the transmission network and the drop in fault level on the transmission network, the actual contribution from the distribution level, because of the amount of generation being connected into there, will increase significantly. So we see a year-on-year increase in fault level conditions from our 2016 picture. So it's something that we need to be aware of and accommodate. We've identified a number of recommendations from 2020 onwards. These are all identified in the report. I've highlighted a few in the results slide, but we certainly welcome people to have a look and make sure that they're sort of aware of the works and the investment plans that we have going forward. We're also started to develop options for the 2025 reinforcement, which includes new GSPs and new supergrid transformers. So again, we're doing a lot of work, joint work with either adjacent network operators and National Grid to make sure that they have visibility of our plans and make sure they understand where we think the network how the network might need to be modified in order to accommodate our future customer growth. We are also seeing that we can potentially use other technologies such as network management and automation in order to continue to deliver a network that's technically within limits, but accelerating customers onto the network. But we found that these studies are very helpful in terms of understanding how the network works and how the network will need to work out to 2030. So we will definitely be repeating the studies in a 2-year cycle along with the other 4 license areas in order to maintain intelligence and provide customers that information. So looking to the future, WPD has recently published its distribution system operator strategy document on our website. This really documents our proposed transition from being a network operator, so one that looks after a passive network, to being a system operator where we manage an active network, have visibility and control of lots of resources across our network, and we make sure that we efficiently and economically delivering that service and doing it in a coordinated manner as well with the transmission network operator. So this document is out for consultation at the moment. I would really recommend customers to go and read that, and we would really welcome any feedback, any thoughts to that consultation. Just recently this week as well, BEIS and Ofgem have delivered their Smart Systems and Flexibility Plan. This is very much a clear direction for how distribution network operators need to engage with the whole of the energy system and customers, and understand how we are going to be altering the way that we run our network and how we plan to run our network to accommodate future customer needs. So we will definitely be revising our DSO strategy in line with this current publication, but really focusing on the key aims of that document there, which is to remove the barriers to getting smart technology onto the network, helping businesses and homes become smarter, and also facilitating those markets which work for flexibility. So as I say, A&M can be one of these particular devices that we can look to implement across our network. Within our DSO strategy, we have a rollout of A&M for all 4 license areas across the whole of our network by 2021, and this will help us accelerate customer connections onto the network quicker, but also help us do some of the smarter elements of network operation and allow customers greater access to a number of markets to help them help us manage our constraints. So it's not quite a silver bullet. There are some pros and cons for A&M connections, but I think that as we start to see flexibility playing a more key role on network operations, then we will see some of the riskier parts of A&M and the benefits of A&M being spread more equitably between customers, network operators, and other participants in the energy sector. We also see that whole system coordination is increasingly becoming more important. We mentioned earlier on about the statement of works process that we have trialled across a number of our GSPs to update National Grid with a more up-to-date picture of what our network capacity requirements are and where we think they're going into the future. We're also working with National Grid on a regional development program that is specifically looking at the southwest license area, but it's looking at more collaborative studies so that we can approach reinforcement on the network in a more coordinated fashion and look at transmission and distribution solutions for both of those particular issues, and try and go and deliver a more efficient and economic network. So a key question is, how should these works be financed? We obviously apply our charging methodology, which is approved by Ofgem, and this is the general methodology really here is where customers who are triggering those works that upset the status quo of the network, where they can be easily identified and it's appropriate for them to be charged for that particular work, then they should pay a particular percentage of that reinforcement costs. However, some of these more incremental requirements for developing a larger network, such as distributed low carbon technologies, electric vehicles and heat pumps, because those are more incremental growth rates and harder to attribute to a particular individual customer, then they will be socialized, and this will enable us to make sure that where we do socialize costs, it is to a minimum, and it's to the best advantage of everyone connected to the network. So there are a few other issues that we have identified within this work. We realise that we need to be a bit more clearer to customers when we place caveats in connection agreements about abnormal running arrangements. So we're working to make sure that we can more readily understand those, and where they can be easily identified, we put them into our connection agreements. But better commercial rights for those customers is clearly the way that we should be heading, so that when people are trying to invest into the network, they have a more defined right and expectation of what they should be getting for their connection. That kind of feeds into the P2 review, which is our security of supply standard. And as the needs and requirements of networks change with low carbon technologies and additional generation on there, we need to make sure that that document is changed. So that will be one of the key outputs for us as an industry over the next few months. Specifically for WPD, then we've started looking at our own distribution system operability framework. This really highlights issues that we feel strongly about on our network, and it's designed. This document is designed to start a conversation about how particular issues on the network might be solved, not just through traditional reinforcement or thinking from the network operator's point of view, but from engaging the wider energy sector into helping us solve those issues. So this DSOF publication will be published on our website towards the end of the third quarter of this year, so before September. And in doing so, we will be highlighting 11 different issues, 9 of which are displayed on the screen here. And they basically give a little bit of an overview about what the issues that we see going forward are going to be important onto the network. They're designed to stimulate and engage a bit of a discussion, and we'll be having regular stakeholder meetings with customers and other participants in the energy sector who think that they can help us alleviate or at least manage some of these issues that we are seeing on our network. So in summary, this is the first time that we've undertaken such a comprehensive look at the East Midlands network and understand how we think that the network may be required to grow out to such a long period of time. We see that there is a massive potential change in generation demand depending on the adjacent political and economic factors, but we are looking at a wide range of solutions there and a wide range of scenarios, and that hopefully should give us enough tools in the toolkit to have a plan for whatever the future brings. So it really brings additional flexibility for us. We've identified that there's further work with National Grid and with adjacent network operators, and so we'll be continuing to progress that and making sure that we're doing it in a coordinated and cooperative fashion. We've highlighted a number of issues under our DSOF, and as I say, this will be published in the third quarter of 2017. So I definitely invite people to take a look when that comes out. And to reiterate that this is part of a long-term cycle of assessment as well. So there's a 2-year rolling window which we'll be looking at our 4 licence areas, one every 6 months. We're just embarking on the West Midlands network, and some of you indeed may have been to our West Midlands stakeholder engagement event. And we'll be continuing to look through the West Midlands network over the course of the next 6 months to do a similar type of study as well. So I'd like to thank you for your time today to review some of the outputs of this shaping subtransmission work, and I'd like to start to answer and address some of the questions you've kindly put to me. So if you have any further questions, then please do type away into the question dialog box of this webinar. And whilst you do so, I'll start to ask some of the questions that have already been put to us. Thank you. So we've had a question in from Christopher Randall. Thanks for that, Christopher. And this is related to the announcement by the government. I think it was yesterday, where they have a vision for most cars and vans to be zero emission by 2050, and that will require more electricity generation in the UK. So Christopher's question is there a role for managed and or bi-directional charging vehicle to grid in conjunction with local renewable energy production in reducing the need for low voltage network upgrades? So great question to kick off there, Christopher. So we definitely see that there is a definite role for customer distributed energy resources on the network to be connected and to be coordinated by either the distribution network operator and or the system operator in order to mitigate some issues on the network. I think certainly V2G will play an important part in the future of being able to facilitate cheaper energy storage solutions and responses onto the network. But I think most importantly in the short term, then I guess what we're terming V1G would be really important too. So control of vehicle charging onto our network, just in that one directional point, and that's something that the government recognises. That is important, and has recently announced what was the Modern Transport Bill, but I think now is the Electric Vehicle and Automated Vehicle Bill, and that looks at designing legislation that will enable network operators to control electric vehicle charge point. It's also something that we're exploring in our Electric Nation project. WPD is looking for 500 to 800 electric vehicle owners to provide data on where we see consumption patterns altering, and we're also looking at how we can use those resources aggregated together to provide a response on our network. So certainly, to answer your question succinctly then, Christopher, I think that it's really important that we have a coordinated control of those devices, and I think if that happens in a timely and coordinated fashion, then we can see significant benefits from those technologies connecting onto the network. We also have another question from Nick Bolton, looking at the recent EV announcement and to say whether it makes a large or small difference on our assumptions. Again, a good point. We've been doing these studies for, this is our third one, so we've been doing these for a year and a half now, and I think that we always had the intention, at least on the gone green scenario, of the government trying to achieve this very low carbon, very aggressive and low carbon endpoint around the 2050 mark. So within our scenarios ourselves, then in the 2030 scenario, we are estimating that in the gone green picture, then between 65 to 67% of electric vehicles in the UK will be electric. So I think towards that more gone green scenario, we've already considered that within our existing analysis. So I think that it holds. But what is really important from this recent announcement from the government is that there is some clear direction there and I expect there will be the correct incentives and mechanisms as the government elaborates on its transitional plan about how to go and get to that position. And so we will take that on board, and it may be that we have to more heavily weight the gone green scenario into our future network investment plans. So a further question here from Hugh Taylor. Will distribution level connect and manage be part of your strategy? So Hugh, very much so, yeah. Our distribution system operator document talks a lot about how we're starting to engage with customers regarding using distributed energy resources on a network in a coordinated fashion to help mitigate some of our constraints. And I think that's going to be an increasingly important part of the future there. So specifically for WPD, we've got our entire project, which is actually operational in one of the areas which we recommend for reinforcement in the East Midlands. And that's looking at getting generators to turn up when we have particular load constraints. And it's also looking at how we can develop a commercial package to offer that to customers. At a lower voltage level, we've also got a project running in Nottingham and Milton Keynes called LV Connect and Manage, and that there is looking at how we can develop types of products and services to customers on the low voltage network that may either allow them to have increased access to network, quicker, cheaper, and more efficient connections, or it may allow them to facilitate in future additional markets as well that may become available. So certainly, connect and manage, I think, will be something that we will be heading towards. As always, the devil is in the detail about the commercial type package. So we're very heavily engaging with customers and always welcome to hear from customers about proposals and how that should be taken forward. So a question here from Stephen Hayes on whether our modelling outputs are available to view. Certainly, we've published. Certainly, Stephen, we've published our document and the underlying data assumptions that we've taken in the 2 reports that are available on our network, on our website. So that is our shaping subtransmission report, and then also the accompanying regen support. I think if there was a specific area that you wanted further details on, we can always arrange a future discussion on that. I think we've been quite open and honest about what data we've used, and we may find some sort of further elements for collaboration if you have other data scenarios that we may want to take into account. So a message here from Peter Jones regarding a centralised approach for negotiating larger scale suppliers of renewable power, a single point of contact to understand their role. So as a network operator, we don't operate any generation assets, and we don't directly buy the electricity in order to distribute around our network. We are just purely moving kilowatts around our network. However, we are starting to buy commercial services from those distributed energy resources in order to manage our network. So, Peter, I'd recommend that you move towards, have a look at our flexible power website. It's www.flexiblepower.co.uk, and that is our single point of contact there for looking at what commercial services WPD are looking at getting involved in. So I definitely think that there's probably some further work there to do to understand what we're offering in that marketplace at the moment. Okay, another question here from Peter Jones as well. To what extent have you factored in domestic self-sufficiency via rooftop PV and domestic batteries? Again, great question, and that's really pertinent on these particular studies. So traditionally, we've got great data on how customers use the network passively, and how load growth has been fairly incremental from the early years of electrification. What we are finding increasingly challenging now is how customers are changing the way that they use energy, particularly around times of the day and seasonality of that as well across the year. And certainly a lot of our innovation projects are looking at how we can get better data on how we think customers are and will be in the future using their energy. So in terms of how we've used that data, we've certainly on a lower level, we have aggregated up the rooftop PV figures and split them down into what type of output that those particular generation technologies would have on the net residual load or demand that we will find at each of our network exit points. But because this particular study has been focusing on the subtransmission network, then really we've been concentrating on the higher voltage networks. As that trickles down and as the analysis trickles down into the lower voltage networks, I think that is an increasingly important area that we need to do further research into. Now, we understand that most PV and battery systems combined at the moment are really there to make money back for the end user, and so they maximize self-consumption. But we also see quite a lot of interest from battery manufacturers and battery resellers around allowing these devices to be aggregated up to provide services back up to the transmission system operator. That presents quite a significant problem for the distribution network operators, because when a system issue manifests itself on the network, may not be exactly the same time as when we have lots of distribution capacity. So we could find that as a nation we need more generation, but there might be localized constraints on the distribution network that would forbid extra capacity being pushed out onto the network. So we really need to work more closely together with our transmission system operator in order to understand what our constraints are on the network, what their services are. And this is very much explored in our DSO strategy paper, where we propose a number of market models about how the coordination of transmission and distribution systems can be operated closer together to get the better economic and cost-effective outcomes that we need to do in order to deliver all the capacity that our customers require. So in answer to the original question, then we have factored in domestic PV, car charging and domestic loads into there, and we certainly understand the impacts on a transmission or sub-transmission level. We'd have to look through to some of our other innovation projects, such as Electric Nation or LV Connect and Manage, and some other monitoring projects to really understand the localized LV conditions. But I would definitely say that there is much further work that we will be doing in there, and certainly we see the direction of travel as we move from a DNO to a DSO to be one where we have to be more understanding of how customers use their energy at a local level and how we can try and influence that within the boundaries of our existing network. Okay. That's all the questions that we have put to us at the moment. We can pause a little bit while if there are any further questions that are coming in right now. Now's your time to ask. But if not, then I'd like to thank everyone today for attending this webinar and putting the questions to us. If there's any more sort of collaboration that you would like to receive, then we're more than happy to take sort of inquiries into our mailbox in there. We definitely recommend that you look at either at our DSO strategy document and also the output from the East Midlands study. If you've got any specific inquiries or queries about how we carry out the work or how we could possibly use this data for other purposes, we certainly welcome more further collaboration in there. Okay, thank you very much for your time today, and I hope to be seeing you at some of our events in the future. Thank you.